In this video, I'll solve this question that says prove that cos A cos 60 minus A into cos 60 plus A is equal to 1/4 cos 3A. See, this question can be done using these three identity on expanding cos A plus B, cos A minus B, and applying cos 3A in the reverse order. So first we'll apply this identity over here. As you can clearly see, this is cos A minus B. And over here, this is cos 60 plus A will be expanded using this identity. So if I expand this LHS, cos A is as it is. I'm expanding cos 60 minus A, which is cos A cos B, applying this, right? Cos A cos B plus sin A sin B. This is cos A cos B plus sin A sin B. This is sin A sin B. And then applying this one over here, this is cos A plus B is cos A cos B minus sin A sin B. So it's everything is same. There is a minus in between. Cos A minus sin 60 into sin A. So what you can do in the next step, just replace this cos 60 with its value, that is half. This cos A is as it is. Sin 60 can be replaced with √3/2. Sin A copied. In the next part, you can see this is cos 60, which is half again, and then that is cos A minus sin 60, which is √3/2 into sin A. You can take, as you can see, half is common, right? Half is common. You can take out this half common. So half into half, like say, I mean to say that if I'm taking half common from this part and another half common from the next part, I'll get half into half is 1/4. Why doing so? Because I can see that in the RHS, we need 1/4. That was the reason I'm taking common. So straight away, I'm writing 1/4 here. So what we are left with, the remaining is cos A plus √3 times of sin A. And then over here, this is cos A minus √3 times of sin A. Now, after that, we can clearly see there is an identity applicable here, A plus B into A minus B. So you're applying this identity, that is A square minus B square. So what we'll get, this as 1/4 cos A, and this will become cos square A, that is A square, minus square of this, √3 square is 3, and then sin square A. Well, you can see in the RHS, we just need sin 3A. We don't need any cos term. And as you know, sin 3A can be obtained using this relation, that is 4 cos cube A minus 3 cos A. So we are going to replace this sin square A using the relation that sin square A plus cos square is 1. That is, I can replace this sin square A as 1 minus cos square A. So let me make some space here. Right, so this is our LHS only. 1/4 cos A. Let this cos square A be as it is. And I can write 3, replacing this sin square A as 1 minus cos square A. In the next step, apply distributive property, open the bracket. So what we are going to get is cos A into cos square A is, okay, we can wait for this. We can do in the next step, as it will be difficult to understand at this stage. Let this be as it is. And reduce the one which is inside the bracket. On opening the bracket, it is minus 3 into minus minus plus 3 cos square A. On the remaining part, I'm doing over here. This is 1/4 cos A bracket. These are like terms. So I can write this as 4 cos square A and minus 3. Now, finally, if I open the bracket, what we'll get? Cos A into 4 times cos A, right? That is, let's not indulge this outside 4. As you can see clearly that this 1/4 is part of our RHS. So do not indulge this with the remaining part. So let's first place a bracket. Multiplying, applying distributive property, we are getting 4 cos cube A minus 3 cos A. That is equal to, now finally, applying this identity in the reverse order, the RHS as LHS, so 1/4 copied, and you can see this as, this can simply be replaced with cos 3A, and that is equal to the RHS.